I recently had to look at a problem with a 116i N45, same as mine, so in that range of 2004 to 2006. And the problem was that it would crank, but it wouldn't start. And what we found was that the power to the injectors wasn't coming up. So it would crank okay, but it was you just didn't get any, no attempt to start. Now, to cut a very long story short, what we found was that the EWS circuit here, which goes from the CAS unit, which is up here, to the DME, this was shorted to ground. Somehow, during the modification of the car, a wire had chafed, or maybe a screw had been put through, a self-tapping screw or something had been put through the wire. But anyway, some way or other, this had got shorted to ground. It took a while to find this, and it was really just done through research. There was a hint on the scan tool that my friend was using, in that it did say that, and it didn't do it all the time, but it would occasionally come up with a thing that said DME EWS comms failure. And that's what led us down this route. And then my friend Robin just put a bypass in. So he cut the wires here and here, bypassed the loom, and sure enough, it fired up and it all started okay. Actually, kudos to him, because he was the one who found the short to earth. I just did the research to look into why this might be occurring, this problem. What I thought we'd do is look at the signals on this circuit here, EWS, and this one here, which in the documentation it's described as convenient starting. Now, I don't think I have convenient starting on my car. I don't completely understand what it is, but we will look at this one as well, because in fact on the car that we had the crank, no start problem, both of these were shorted to ground. So it's best if we look at both of those circuits. To get access to the circuits, I'm coming in through here through the ECU box, and I'm using these sheath penetrating probes. They're a bit controversial in that a lot of people are concerned they damage the cabling and whatnot, but there is also some dangers in back probing, actually. I'm not sure it's going to cause any problems, and I've got them just on there and just about touching the, pushing through the sheath and touching the conductor inside. I probably will put a dab of liquid tape on them just to be sure they're sealed up, but being inside the ECU box, they're not really exposed to anything nasty, so we should be good. As you can see, I'm using my electronic oscilloscope. I've done, as you've probably seen in my series of baseline videos, I've used this oscilloscope repeatedly. It's worth saying that you can get really cheap, simple oscilloscopes, and you can do just about everything that I'm doing with this scope with a cheaper one. A popular scope is the picoscope, the cheaper of the picoscopes, which looks really good. I like the fact that you can use it. It's integrated into a PC, and it's got a lot of facilities that I simply don't have on my scope. The top trace is the EWS trace, and the bottom trace is the convenient start signal. So I've got them both nominally set to ground, but if you look at the this is a bit strange on channel 2, which is the start thing, the convenient start thing. If I switch the measurements on and we look at channel 2, you can see there's about 800 millivolts of noise versus 400 millivolts of noise on the EWS circuit, but noise is just one of those things. I wouldn't take too much notice of that. But the thing I do know is that there's an offset. So we've got a baseline of 800 millivolts, which is strange. That's really weird. I don't know why that is. So if I change the coupling on this, let's see if I can do this. If I change the coupling to ground, oh, that's channel 1, wrong one. Let's go again. Change the coupling to ground on this one. You can see that it drops. So there's definitely a DC offset on this circuit, and bearing in mind at the moment I don't even have a power applied to my car. My isolator is activated, so goodness only knows where this offset's coming from. It could be, I don't know, maybe inside one of the ECUs it's got a battery that maintains the memory. I don't know. It's really weird. Could be some sort of leakage out of the isolator, I guess. That could be another good reason. Anyway, let's stick it back to DC. And I'll turn the measurement off, actually, for the moment. Okay, so I'll go through the sequence. So the first thing I'm going to do is just apply power to the car. So you notice that we've got 12 volts on this, on the convenient start circuit, but nothing much has happened on the EWS circuit. So the next thing I'm going to do is push the key in. Again, not much change there. Still got the same conditions. And now I'm going to press, I'm not going to start the car, but I'm going to, so I haven't got my foot on the clutch, but I'm going to press the start-stop button. Okay, so the two things we see that have happened now is we've got some sort of digital signal flowing on the EWS circuit, and the convenient start circuit has dropped to ground. I think this one's the critical one, because obviously when we saw this error on the scanner that said DME EWS comms failure, then that was a bit of a giveaway that it had to be somewhere there. I have to say, at the time we saw that, we didn't even know anything about the EWS circuit and the fact there was a separate circuit. We thought that the CAS unit talks to the DME over the CAN bus, but in fact in this instance, for the purposes of unimmobilizing, if you see what I mean, disimmobilizing the car, because we've got the correct key in the slot and everything's good and the steering lock has worked, then it's at that point we start to see the comms flowing on the EWS line between the CAS unit and the DME. So if this isn't working, you will get a condition where it will crank, but it won't start. So I hope you found that useful, and I'll catch you on the next one.